for part B. This is page 4. What would be the cost, the total cost, only for 14 square feet? But the additional 14 square feet. How do I determine that?
Did you say for an additional 14
Yes.
square feet?
So we installed the first 50, and now we want to install from 50, 14 more to 64 of the same thing, 4x to 1/3 dx. So this is exactly the same, so it's still the same answer as 3x to 4/3. There is no change there, but this time from 50 to 64. 3 stays outside. We plug in 64. 64 to 4/3 minus. We plug in 50 to 4/3. And that's how we get this answer. So this time there was no glitch in the system. The glitch was at my end. So 64 to power 4/3 minus 50 to power 4/3. So always be very careful when you plug in the integral. You have to plug in the original. Here I'm just calculating my answer, my final answer. So 215.40. So that's the additional cost, and that is in dollars. But now to make sure that what I'm going to do, oops, I meant to do this. That's how lazy people do it. Okay. So this is 64, and now this is 50. And when I click enter, I have to get this number. Yes, 215.40. Okay. Any questions? Any questions? Okay, so let's move on to 4.4. In 4.4, we are going to look at areas between or among, this is for 2 and this is more than 2, among curves or functions, and the average value of a function on an interval. Before we even look at these, let's talk about some properties of the definite integral. Properties of the definite integral. So here's one property. The integral from a to a from f of x dx. Remember, this signifies the area. So if I have a function, this is the function, and this is the interval from a to a, what should the area be? I'm not saying the integral from a to b. No. I'm only saying the integral from a to a. What do you think the area equals to? Yes, the area of a vertical bar is 0. If there is no width, there is no area. Awesome. Good. The integral from a to b from f of x dx is the opposite of the area when I flipped the limits of integration from b to a from f of x dx. This is another property. So if I have the integral from 1 to 5, it's the opposite of the integral from 5 to 1. 1 to 5, the opposite of 5 to 1. Here's another property. Page 5. So let's say I have a function. This is the function, and this is the interval. A, B, C. The integral from a to c from f of x dx can be expressed as a sum of two integrals. Can anyone give it a shot? So the area under the function between a and c can be presented as
A to B.
exactly, and b exactly, from the same thing, of course. Remember, there is no integral without the x. The function could be just one, but there's no integral without the x. F of x dx. Perfect. Okay, and there are many other properties, and I'm just going to mention one together basically. What do you think about the integral from a to b from f of x plus g of x, of course dx, or minus? What do you think this will equal to? Is the same property we used for limits, is the same property we used for differentiation. What do you think? Wild guess. What do you think this will equal to? It's the integral of dx dx, f of x dx, plus or minus the integral from g of x dx. Because remember, this was the same rule. When we had x plus 3x squared prime, we differentiated x, and we differentiated the second function. Same thing here. So the integral from a to b from f of x dx, plus the integral from a to b from g of x dx. Same property. And we use the same thing with limits. If I have minus here, then I will have to have minus here. Perfect. So now let's work on one other thing. I will call it number 5, but it's not necessarily a property. It's the average value of a function on an interval. It's called f average, and the interval a comma b. So it is the integral from a to b from f of x dx, but in front is 1 over this difference, of course, b minus a. So this is a formula. If you remember a long time ago, I told you that this is confusing. It is confusing. Why is it confusing? Because we had the average rate of change, we had the rate of change, we have now the average value, and so on and so forth. That's why this is confusing. A lot of combinations of average value or average rate of change, and so on and so forth. So this was the last one that I promised in chapter 4. So now let's work on these problems, see how we apply anything here. So we are on 426. So let's start with finding the average value of a function on a given interval. Find the average value over the given interval. So let's choose from 34 through 44. And I'm on page 5. No, I'm on page 6. Okay, let's start with 39, and then we choose another. So 39, f of x, an easy one, x squared plus x minus 2. The interval is 0, 4. And we want to find f average on the interval 0, 4. How do I start? How do I write it? Can anyone give us a hint?
Sorry, what was the question?
We want to find the average value of a function on the given interval. We are given this function, and we are given the interval, and we want to find f average on the interval 0, 4.
Would it be 1 over 4 minus 0?
Exactly. Yep, the definite integral from, we say the definite integral from 0 to 4. Excellent. What else? Anyone? How do I continue?
X squared plus x minus 2 dx.
That's it. Awesome. So 1/4 in front. Which function prime is x squared plus which function prime is x plus which function prime is negative 2 from 0 to 4. So this is the second week on this, and I was hoping that we would spend 3 seconds on these steps. That's my hope. Which function prime is x squared?
Would be x to the third over 3
Excellent. Plus.
plus x squared over 2 minus 2x.
Excellent. Luckily, it's a polynomial. I don't have to plug in 0 because everything will be 0. Just this case. It doesn't always happen, but because it's a polynomial. Very good. So then I have 1/4, and I will only plug in 4. 4 to the third over 3 plus 16 divided by 2 and minus 4 times 2. Luckily, this is done. So 1/4. So this is 4 to the third over 3. I will simplify one of these, and I have 16 over 3. Yes, you can always go back and check. So this is the average value, and you go to directly to the integral from, oh, we have to insert 0.25, which is 1/4 in front. So from 0 to 4, from x squared plus x minus 2. It's confusing, be very careful. This is the original function. Do not plug in your antiderivative. So when I hit enter, I have to get 16 divided by 3, and one way will be changing this into a fraction, and it has to be 16 divided by 3. Okay, back to the book. Do we need to determine another? What about
43.
43? Perfect, excellent. So let's look at 43, good pick. So we have y equals 3 divided by x squared on the interval 1, 5. Awesome. Good. So we want to determine the same thing. So f average, the average value, as you know it's a number, on 1, 5. Can anyone give us a hint on how to write the average value? Anyone? Please.
Is it 1 over 4?
Yes, 5 minus 1, very good. The integral from, it's a definite integral from
1 to 5.
that's it, from the function 3 over x squared dx. Please remember there is no integral without dx. If this is t, dt. If this is w, dw. Good. Excellent. So 1/4 stays outside. We want to find the function whose derivative is 3 over x squared. Also 3 stays outside. Which function prime is 1 over x squared? We talked about this formula. It's a very important formula, and that's why we discussed it. Say it again. No, that is for 3 over x, not for 3 over x squared.
Is it 1 over the square root of x?
No. So let's write the formula again. When we differentiated 1 over x, I said this is a very important situation. And this is a very important formula. Now when we are going backwards, the integral from 1 over x squared dx must be negative 1 over x plus a constant c. So this is the indefinite integral, so you see the formula. So please remember, 1 over x prime is negative 1 over x squared. When we go backwards, the integral from 1 over x squared dx is negative 1 over x plus a constant c. So therefore, here we have negative 1 over x. If you differentiate negative 1 over x, it's guaranteed you will get 1 over x squared. So please remember these two formulas. Okay, so then I plug in 5. I put the negative 3/4 outside waiting patiently. I plug in 5, 1/5. I plug in 1 minus 1. So then negative 3/4. So then that is times negative 4 over 5. 1 minus 5 is negative 4. So the negative 4 with negative 4, so the answer is 3/5. So the negative 4 with negative 4 go away. This negative 4 and this negative 4, so we have 3/5. Yes, we can always go back and check. So we had our original was again 0.25 in front, and then you put in the 9. That's fine, it's a different way. No, okay, calm down. I didn't get the chance to do anything. Okay, so that is a 5. The lower limit is called lower limit, upper limit, and this is 3 divided by x squared dx. And the answer has to be 3/5 or 0.6, same thing. If it's not, something is wrong. Okay, good. Moving on to, go back now. Okay, so let's take a look at this set of problems. Let me look at the time, 19 minutes. So let me just stop this video and